Hello, and thank you very much for having me here today. I am Gaia, and I am here to present you the journey and the results of the project Cook.3D. The project Cook.3D is a project that lasted the 2 last years with the purpose of building a new food 3D printer. It is under the umbrella of the bigger project Food 2020, an interregional project, and therefore different partners were involved in the collaboration. Here you can see them. Because of my studies, I had the chance to try different 3D printers for food. In my first experiences, I printed or sometimes tried to print different materials. For example, marzipan, meat, cream cheese, mashed carrots, chocolate. And here you can see the differences between tempered chocolate and not tempered chocolate, icing, and again, meat. But while I was experimenting, I noticed some drawbacks in the current food 3D printers. And those are that they generally show a low automation. The cleaning after use was hard and required a lot of time. In order to use them, it took a little practice and experience. And the types of printable materials was not very wide. Also, sometimes I noticed that the container of the foods to be printed were either too small or too big. So I started thinking which improvements I would have liked in food 3D printers. And I thought that the priority were having an extruding head where food is not in contact with mechanical parts, and therefore having a cleaner and easier to clean machine. Also, I would have liked to be able to print a wider range of foods, especially like everyday foods. On other secondary but also important goals are higher automation for the printer to be more user-friendly, and a post-processing area for example, for cooking those foods that needs to be cooked. So the designing and the building of the machine wasn't a short journey. I started with some research on food 3D printers available on the market, the state of art, and their pros and cons. And the main characteristics were collected in the table that you can see. I think you cannot read it, but it was a table just for me. And also a little note, you will hear me switch from I to we, and this is because of the different phases had different people involved. And during the first phases, it was only me, but later in the project, I was helped by my wonderful team partners. I then focused on the extruding systems used in food industries. I read different books, chapters, and different papers, and started collecting ideas. Here are a couple of those books that I consulted. And in the meantime, I researched on food rheology, behavior, and characteristics. During my studies, one of the main focus was this very same topic, but I needed to refresh my memory. And here again are some of the books that I consulted during this phase. I eventually read about peristaltic pumps, and I thought that since our body moves the food this way, it could have been a good idea to have a similar extruding system. But a flow had to be ensured, and so I thought about adding what I call the squeezing system. I built the very first simple prototypes for proof of concepts. Here there is the CAD, and those parts worked. Here you can see the very first peristaltic pump, very simple and manual peristaltic pump I built. And here was the very first squeezing system. Those parts worked, although not perfectly, but that made possible for me to keep on thinking and optimizing the design of the same concept. So here, what you see here in the drawing was the result of this keeping on optimizing and thinking of the same concept. It is a squeezing system followed by 2 peristaltic pumps. A second peristaltic pump was added to reduce their intrinsic pulsation. And in this system, the food is always confined in a food-grade plastic pouch and a food-grade silicone tube. Here is again the cat drawing of the same system. A first prototype was built and tested with satisfying results. Here are the first peristaltic pumps in series. And here is the squeezing system. You see that I use toothpaste, as it was said just a few minutes ago, because it has a similar texture to food, but it's easier to clean, and most of all, it doesn't go bad, and it doesn't smell bad if it goes bad. And in the meantime, the body of the machine was designed. This allowed being able to produce those parts not available on the market that are shown in this picture, and also to have a bill of material of those that were purchasable. The parts of the printing head and were professionally produced. Here you can see the results. And as well were the parts of the body professionally produced or purchased. Here also you can see some of those parts that were produced. The machine was then assembled, giving us the results you see in the pictures, from the skeleton to the full machine with mechanics, electronics, and all. The machine was tested first without no food to check that the mechanics and the electronics worked. Here was one of the first tests, and everything worked. In a moment, the pumps spinning will be shown here. And therefore, we tried with food. And here you can see also the extruding system worked, and the pumps work well. And they also showed the function of preventing leakage of material when not printing without any need of retraction. Here, a second test. This is cream cheese. And so to conclude, during the project Cook.3D, we were able to produce a food 3D printer, mainly designed and produced in a fab lab. We had a cleaner and easier to clean printing head, and we were able to print a wide range of foods, and there are still many more to try. For example, we printed basil sauce, onion sauce, mustard, mayonnaise, hummus, and cream cheese. But the work isn't finished yet. There are a lot of features that can be added and implemented in a Cook.3D, adding sensors to make the printer more automated and control all the parameters automatically. Here is a simple example of where I would like to put the sensors. Then adding a post-processing area to directly cook, but also to cool foods if they need it. Have a multi-head extrusion system to print with different materials at the same time. Adding feature for people with special needs, like vocal command in case of blindness and others. And also, as it was said multiple times in this conference, develop balanced recipes and smart portioning to meet everyone's food needs. And here is a drawing of the idea that we initially had and that I hope we will be able to achieve in the future. Thank you very much.
Thank you very much, Gaia. It's quite different from what I saw when we spoke, let's say 5-6 months ago.
Yeah, sorry, Peter. I also actually have a video where I printed. If you don't mind, it's in the other screen. Okay. So you can see it?
Yeah.
Okay. So here was the mashed potatoes. They were just leftovers from dinner, and I colored with food coloring to make them more interesting. I use those food coloring, but of course also a natural food coloring can be used. And here the machine is printing a small, very simple boat that I designed on Fusion 360. And here it's printing octopus in different colors. I am going a little bit forward. And by paying a close attention to the tube, it's possible to see that the silicone tube is also acting as a dampener for the pulsations, so that the result is pretty clean. And the flow is pretty consistent. Each piece took about 3 minutes to be printed. So here it's almost finished. The machine also goes down once the printing is finished to be able to take the food easily. And here is the final result. I am not very good at decorating dishes, so probably 3D printers are also very good for me because I can cook, but yeah, my decorations are not the best, as you can see. But I gave it a try.